All right, this first slide just has a couple little pieces of information that we didn't get to yesterday. The first formula at the top there is for a unit vector. A unit vector is a vector that is 1 unit long. So that's what the formula is going to calculate. If you're given a vector, we can basically shrink it down to make it 1 unit long. So we'll do that real quick. It says find a unit vector in the same direction as vector v, which is negative 12, 5. Remember those little pointed brackets mean it's a position vector already for us. So that vector, if I drew it, starts at 0, 0 and ends at negative 12, 5. All right. That's okay. Use your notebook. Share with somebody. Either one's fine. All right. In order to use this formula, you need to start with the magnitude of v, which we did this yesterday. That was our Pythagorean theorem. Remember, negative 12 and 5, we can think of like 2 legs of a right triangle, and the length of the vector is like the hypotenuse that we're trying to find. So I would do 12 squared and 5 squared, and you can put the negative there if you want, but we know it's always going to be positive anyway, which is just going to give you 169, and then take the square root of that, and you get 13. Okay? Okay, then restart it. You just hold the button in, and we restart it. The top. There you go. Just hold that for like 30 seconds. All right. So this is the formula. We do 1 over the magnitude, 1 over the length, and then we just multiply it through the vector. So we do 1/13 times the vector negative 12, 5. And then we did ones like this yesterday. You just distribute it in. So final answer here is negative 12/13 and 5/13. And you can make a note to self here if you want to check this. The magnitude or the length of this vector, because it's a unit vector, if you do the Pythagorean theorem with it, should equal 1. Okay, so you can make sure that's right. Quick little formula. Questions on that, getting a unit vector. Okay. At the bottom, IJ form, sometimes called linear combination form, is another way to write vectors. Vector I is a position vector, you can see it in the picture here, that just goes 1 unit to the right. And vector J is a unit vector that goes 1 unit up. So we have a horizontal component and a vertical component. I can put a bunch of those together to get new vectors. If I have a vector like, let's say I have the vector 5, 3, that's in standard form how it's written. I could also write this as 5i. I have 5 horizontal components, and 3j. I have 3 vertical components. So it just creates another way for us to be able to write vectors. So if you see an I and a j, just know the number in front of the I represents that first component, the horizontal piece. The number in front of the j represents the second component, or the vertical piece. Okay, and again, this is sometimes called linear combination form. If you see that, that's what this means. Questions on that? Cool, moving on. All right, so if I have vectors in IJ form, we can do calculations like what we did yesterday. If I see 3u plus 2v, I'm going to set it up, fill in my vectors. 3 times vector u is negative 3i plus 2j, plus 2 times vector v, which is I, plus 4j. This is really just like algebra 1 stuff. We're going to distribute and combine like terms. Bless you. If I distribute, I get negative 9i plus 6j, 2i plus 8j, and then combine together my like terms. So I have a negative 9i and a 2i, which give me negative 7i, 6j, and 8j give me a 14j. So you could leave your answer like this, or you could write it in that position vector form, negative 7, 14. They both mean the same thing. Okay. MathXL will be specific. It'll say put it in linear combination or IJ form. What do the bars on the second one mean there? What do the double bars mean? Magnitude. So What we have to do on this one is find this vector first, do that calculation, and then find the length of that vector as our last step. All right, so I'm going to do the part on the inside. Vector v is I plus 4j minus 4 times vector u, negative 3i plus 2j. Okay, and I'll just bring my bars down on either side of that. I'm just going to simplify everything on the inside. I'm going to distribute first, get rid of my parentheses. So that would give me a 12i and a negative 8j. And then combine together my like terms. I'm going to have a 13i and a negative 4j. So now we have that as a single vector. So then if the bars are on the outside of it, it's asking us to find the magnitude. Our answer is going to be the length of this vector, a single answer. So it's just your Pythagorean theorem. You do not use the I and the j in the formula. Think of the I and the j just as a label, horizontal component, vertical component. It's really just those numbers out front, the 13 and the 4 is what you're plugging in. All right, so 13 squared plus 4 squared gives me 185. And I don't think that one breaks down. Okay, so really similar to what we did just yesterday. I just wanted to show you what it would look like if there were i's and j's instead of the position vector brackets. Okay, questions on that? All right, our last few problems today are going to use this formula. Circle it, or star by it. We're going to use it a lot. This is another way to write a vector. The first part of the formula is the magnitude or length of the vector. And now our trig functions are going to come in. In front of our I, we have a cosine theta. In front of our j, we have a sine theta. Now, do you guys remember cosine and sine, respectively, were the x and y coordinates on our unit circle? That's why they're showing up here. The number in front of the I is the cosine, it's the horizontal component. The number in front of the j is the sine, it's the vertical component. Theta is our direction angle. A direction angle is just like our standard form angle that we were using on a unit circle. It's how far we have to rotate from the positive side of the x-axis counterclockwise. It's going to be a positive angle that we plug in. So if we can figure out how long a vector is, and we can figure out the angle of rotation that the vector has to get to that positive side of the x-axis, we can figure out how to write the vector. That's what this formula is for. Okay. So let's do that on this one. It says write the vector that has a magnitude of 2 and makes an angle of 11 pi over 6 with the positive x-axis. So again, that formula was magnitude times cosine theta I plus sine theta j. Cosine first, sine second, just like our unit circles. And here they give us the theta and the magnitude. You just plug them in. So 2 cosine 11 pi over 6 I sine 11 pi over 6 j. What do you think we're going to do now? Unit circle. What is the cosine of 11 pi over 6? It is rad 3 over 2. I. The sine of 11 pi over 6. Negative a half. Still j there. And then distribute your 2 in. What's going to happen when I distribute my 2 in? Yep, and we could just write minus 1j, or you could just write minus j. You don't even need the 1 there if you want. Okay, you could also write your answer like this, rad 3, negative 1, if you like that form better without the I and j, means the same thing. Okay, so it allows us to get the vector if we know some information about it. At the bottom, we have the vector, 2i minus 3j, and we want to work backwards to find the direction angle. So we're going to draw a picture. Okay, so remember, if it's ij form or it's position vector form, it starts at the origin, and then 2, negative 3 is where this vector ends at. So you can plot that point. So it's going to look something like that. And make your little right triangle. 2, negative 3. Okay, we need to find the direction angle, which is the angle from the positive x-axis rotated counterclockwise to get to that vector that we have. So what should I probably solve for first? Not the hypotenuse. Well, I could solve for that, but that's not going to get me really any closer to the angle. How about, like, let's call it a theta on the inside there. And what trig function am I going to use? It's a right triangle, right? So sine, cosine, tangent. Yeah, you can just use tangent. Tangent of theta is your y over your x, and you do not need to include negatives in this. It's not going to make a difference because we want a positive angle in there anyway. How do I get rid of the tangent? Okay, so do inverse tangent. Make sure you're in degree mode. Inverse tangent of 3/2. I'll just round to the nearest tenth. I get 56.3 degrees. So then you can use the picture to figure out what you need to do with that number to get the angle that you're missing. So let's call that alpha, the big rotation angle here. How do I get alpha? $360 minus the 56.3, which gives you 303.7 degrees. Okay, so just make sure when you have a direction angle, it matches with whatever quadrant your vector's in. This is a vector in quadrant 4, so I should expect an angle in quadrant 4, so on and so forth. Okay, questions there? Okay, those are the only formulas that show up in this section. The last 3 questions are going to be applications of things that we've talked about already, and mostly these formulas on this page are what we're going to be using. So when we talked about a resultant yesterday, that was adding vectors together. Now we're going to talk about doing that in real life. We're going to have 2 forces of some kind. It might be like a speed or it might be a weight. We're putting them together and we're trying to figure out what is the new force that's created. And we're going to start with this one. It says find the magnitude and bearing of the resultant of 2 forces, F1 and F2, where F1 is a 40-pound force acting northward and F2 is a 30-pound force acting westward. Okay, so you are going to have to know your cardinal directions here. And as always, we're going to make a picture to start. We're going to draw both of these vectors. We're going to figure out what the vectors are, and then we're going to add them together to get the new resultant. Okay, so force 1 is a 40-pound force. Whatever your number is the length of the vector, remember, the magnitude of the vector, and it's acting northward. So force 1 is a vector that's going north, and it's equal to 40 in length. Okay, force 2 is westward, so that would be going to the left in my picture, and it is 30 pounds of force. Okay, now we're going to use the formula that we just practiced to figure out what F1 and F2 are. We're going to use their magnitude and angle to write the vector. Starting with F1. What is the magnitude of F1? Magnitude of F1. Length of F1. 40. Okay. Then cosine theta I plus sine theta j. And it's going to be the same theta for both of them. Your job is just to figure out what is that theta. And theta, remember, is from the positive side of the x-axis rotated counterclockwise. So how far do I have to rotate to get to F1? How many degrees? 90 degrees. What is the cosine of 90? Zero. And what is the sine of 90? 1. If I distribute the 40 through, my final answer is going to be 0i plus 40j, which kind of makes sense with the picture. Remember, j is the horizontal, or the vertical vector, and there's 40 of them stacked on top of each other when I have a vertical vector that's 40 in length. All right, we're going to do the same thing for F2. What is the magnitude of F2? 30. What is the angle for F2? 180. This one. Okay, what is the cosine of 180? -1. What is the sine of 180? Distribute your 30 through, you're going to have -30i plus 0j. Okay? All right, to get your resultant, add them together. If I add F1 and F2, I get R. Add your i's, add your j's. If I add my i's, 0 and -30 give me -30i. If I add my j's, I get 40j. And you can draw that picture. Starts at the origin, 30 to the left, 40 up. There's R. It's going to be in quadrant 2. All good so far? Okay. Last thing we have to find is the magnitude of the resultant and the bearing of the resultant. Let's start with magnitude. Magnitude is just the length of what we found. It's our Pythagorean theorem, 30 squared and 40 squared. You could even draw the triangle with R if you want to and see the Pythagorean theorem. In this case, it's going to just end up being 50. This is a 3, 4, 5 triangle that they've just multiplied everything by 10. We want to label it. In this case, the numerical components represent pounds of force. So that's what I'm going to label my magnitude as. So the resultant will have 50 pounds of force when I combine those two forces together. The other thing we're looking for is a bearing. Can you guys tell me if this is north, south, east, west? Where's that resultant going? Which direction? Okay, so we know it's northwest. We're just trying to figure out how many degrees northwest. Now, when we say northwest, it means from the north to the west. Okay, so from the north to the west, we've got to figure out that alpha. So what we're going to do is look at this right triangle, find the angle inside it first, call it theta if you want to. How are theta and alpha related in that picture? They add up to 90. They're complement. So once I have one, I can just do 90 minus to get the angle that we're looking for. Now, the bottom of that triangle is 30. Going up the side of that triangle is 40. How am I going to solve for theta? We did it on the last page. Just tangent again. You don't need to worry about negatives. Tangent theta is opposite over adjacent. 40 over 30. Do your inverse tangent. And you get 53.1 degrees, which means alpha, if I do 90 minus 53.1, is going to give me my bearing, which is 36.9 degrees. So those are the two pieces, the 50 pounds of force and the northwest 36.9 degrees that this problem was asking for ultimately. So there's a few steps to these. You have to find each of your vectors first in IJ form. You have to add them together, and then once you have the resultant vector, that's what you use to answer the question. The length of that resultant vector is your magnitude, and the direction of your resultant vector, and I think drawing the picture really helps here, is going to help you with your bearing. So we're going to do one more problem like this to practice this kind of idea here. Any questions on any of this, though, right now? Okay. So on the next page, you will see a problem about, oh, I don't want to do that one. What do I want to do? I want to do the plane problem. Go to the next slide where it says the F-15 fighter jet. You guys have that one? Yes? No? Yeah? Okay. All right. It says F-15 fighter jet is flying over Mount Rushmore at an airspeed, speed and still air, of 800 miles per hour with a bearing of northwest 60 degrees. The velocity of the wind is 40 miles per hour in the direction of southwest 30 degrees. We're going to find the actual speed and direction of the plane, and then we're going to round our answers to the nearest 10. We're going to draw a picture to start. What? Why is that funny? Well, yeah. I mean, that would be helpful. We want to plan ahead, though. Okay. So let's start by drawing the plane's vector. Call it vector P. The plane is flying which direction? North, west? Okay. And it's flying northwest 60 degrees. You have to be careful with bearings. Northwest means from the north to the west. This is 60 degrees. And the speed it's flying is our magnitude. So that vector is 800 units long. Do the same thing with W. My wind is southwest 30 degrees. So that means from the south to the west, 30 degrees, and the wind is 40, so not drawn to scale here, miles per hour. So the magnitude of that is 40 in length. Okay? All right, let's figure out what P and W are. Start with P. What is the magnitude of P? The length of P, 800. Okay, then cosine theta I plus sine theta j. All right, be careful here. It is very tempting to want to put 60 in the formula. Do not put 60 in the formula. The theta that you need to use is always from the positive side of the x-axis, it's a unit circle angle, okay? So I have to rotate 90 to get to my y-axis plus another 60 to get to vector v. So how much, or vector p, how much do I have to rotate total? 1, how much? 150. Does everybody see that? Okay, 90 plus another 60 to get to vector P. All right, let's do the same thing for W. Set it up. W is 40 in length. And again, be careful with the angle. How much do I have to rotate? I have to rotate 180 to get here, right? And then how much more to get to my wind vector? What's this angle here? That's going to be another 60, right? Because I have 30 left over. Okay, so 180 plus 60 gives me 240. This is vector W down here. Now these are unit circle values, but we're just going to use our calculator. Okay, so what we're going to do, we're going to distribute the 800 in and the 400. So I have 800 cosine 150i plus 800 sine 150j. I'm going to do the same thing for the wind. 40 cosine 240i plus 40 sine 240j. And then we are going to add them together. You could simplify each individually if you want to. Adding them together to get the resultant is really what we're looking for here. So in your calculator, the numbers in front of the i's are what you're going to add together. And then the numbers in front of the j's are what you're going to add together. Okay? So try it with me. Make sure you can get the numbers in your calculator, okay? Make sure you are in degree mode. For the i's, you have 800 cosine 150. Make sure you end the parentheses. Plus 40 cosine 240. Negative 89.28i. Plus 800 sine 150 plus 40 sine 240 will give me 365.36j. Good? Okay. Luke? You got some, oh, wait. I put an 80 instead of an 800. Hold on. Let me edit it. Need an extra 0. Let's try that one again. 700 something? Yeah. Okay. Negative 712.82. Okay, better. Thanks. Okay? Yeah? Can you tell me what quadrant R is going to be in? You want to sketch it? First component's negative, second component's positive. It's going to be in quadrant 2. So I'm going to draw that guy on its own, just so we have a nice picture to use. So R is in quadrant 2, and you can label it, guys. Negative 712.82 is the X. 365.36 is the Y. Okay. Two parts that are going to answer this question. Magnitude of R is going to be the actual speed of the plane. Just use your Pythagorean theorem. You do not need negatives. 365.36 squared. And then don't forget to take your square root. I get about 801, and this is the actual airspeed, miles per hour. So the plane in still air was going 800 miles per hour. So what did the wind do to it? Made it go a little bit faster. It's going to fly 801 miles per hour now. Second part of the question wanted to know the bearing of the plane. What direction is the plane flying based on that resultant? North, south, east, west? It's definitely flying northwest. We've just got to find that bearing. So we're going to look for alpha. I'm going to get theta first. How do I get theta? Tangent is y over x. 365.36 over, you don't need the negative, 712.82, and just do your inverse tangent. Give me the same steps every time, no matter what quadrant this is in. The only thing that's going to change is your direction, maybe. Helpful to have the picture, I think. So I get theta is 27.1 degrees. So how do I get alpha? -90 27.1 gives me 62.9 degrees northwest is the actual bearing of the plane. Okay. We're not going to do the last example. I do want to tell you, though, if you see a problem that says equilibrium, after you find a resultant, some problems may ask, what vector can you add to the resultant to get equilibrium? Equilibrium means what can you add to it to get 0 for it to cancel out? Well, if this is my R, what would I have to add to this to get a 0 for both of these? Just the opposite, right? It's positive 712.82 and negative 365.36. So if you had a problem that says what vector can you add to all the other vectors to get equilibrium, to basically make the plane stand still, it would just be the opposite of your R. That's an R there. Okay, so just make a little note of that. So these problems, none of this is like difficult trig. This is all just right triangle trig stuff. It's unit circle angles. There's just a lot of little pieces. Don't try to do too much of this in your head. Start with as many vectors as they give you and use the cosine sine formula. Once you have all the vectors, add them together, draw that resultant, and that's going to help you get your final answer. Okay? All right. Okay, that's it for 7-4. I'm going to stop there. Your 7-4 Math Excel, you don't technically have any homework this weekend. It's due Tuesday night. So you guys will have Monday and Tuesday next week to work on it. You can get a head start if you want to, but you don't need to. All right? And then no circuit training due next week. Your vector circuit training is due the following week, but you get a head start on that if you want it all too also. All right, that's all I got for you.
Are we supposed to bring vectors to the pepper lake?
Yes,
What?
I think so. Take your stuff with you to the pep rally? I think.
I thought we used to leave our back.
See, I mean,
People do.
you can leave it here if you want to. I don't know. I feel like I haven't seen anything in so long. I would hate for you to go down there and then they send you back up with the bag, though.
Yeah, I
That would be.
guess.
Cell phone line winner is 7. Yes. There you go. Okay.
Finally, I'm putting 7 every day this